Find the volume, creating cross sections perpendicular to the y-axis. So here's my little graph. The green is this graph. Y equals 0 is the x-axis. X equals 1 is this line. X equals 3 is this line. The little green space is what we're dealing with. From this green space, we are creating squares straight off of this paper. So the squares are going to come up out of this paper, and what's going to happen is this orange line represents kind of a cross section of it that is the kind of the base of the square. Or it's also the base of the semicircle, because you're also going to do squares and semicircles. So this is the base or the diameter of a semicircle. And the reason it's perpendicular to the y-axis, that's why my lines are this way, because my lines are perpendicular to the y-axis. If it was perpendicular to the x-axis, my lines would be vertical, because those would be perpendicular to the x-axis. Perpendicular means 90 degrees too. Okay, now right here what you see is values. Y of 1, when you plug in 1, gives you 3. So what that's saying is at 1, bam, it hits at 3. That's a height of 3. Y of 3, at 3, when you plug it in, you get 3 plus ln 3, which I'm just going to leave like that. Don't worry about a decimal. That is my height right here. What you're going to find, this problem's kind of weird. What you'll notice is you have to have two different intervals. For this interval, from here to the red line, what you'll notice is the interval is always a width of 2. That's actually really simple. The width of 2, the whole thing, it's a width of 2 all the way to that red line. But once we get to that red line, from there, the interval is changing according to the function right here. And the function now, the length of the new red orange line would be a little function right there. And don't we have to change this equation to be x equals to find that? So if we take this function, make it x equals. So that would be y minus 3 equals ln x. And how do you get x out? Well, isn't ln base e? So I would write this as, I'd bring the base e, and then I'd switch two things. So this is going to be e to the y minus 3 equals x. So that is my new equations in terms of x. That gives you the green graph, but referencing it from the y-axis, not from the x-axis. Okay, so here's how you'd set this up. If I'm doing perpendicular cross sections that are squares, for the interval, the first interval, this is volume. For the first interval, from 0 to 3, well, my radius, sorry, my base, isn't my base 2? Oh, by the way, yeah. So this, my base is simply going to be 2. And aren't I squaring it? If my base is 2, aren't I going up 2 as well? So for this, am I going to go over 2 and also up 2 to make a square? And isn't this dy? That's my first piece. Plus, my new interval is now from 3 to, it's kind of weird, but 3 plus ln 3. Kind of a weird interval, but you can do that. And your function for this one, well, it's not just going to be e to the y minus 3, because e to the y minus 3 gives you from here to the green graph. I went from the green graph to the blue line. So won't that be 3 minus e to the y minus 3 squared dy? That would give you the function from the green graph to the blue line, which that's the length we want inside of the shaded region. Okay, so the first piece is a constant. The second piece is changing according to what the green line length is. And if you take the time to do that, we're not going to do that right now. That's all I care about. Can you set it up? That's the key. Can you set that up? We're good to go. We can use a calculator now to solve this. To do this on a calculator, I would just do all this, but make this a y, an x. and you can do it with your graphing calculator, find the answer. The key to me right now is setting things up. Okay, now for semicircles, to find the area of a semicircle, first of all, we did it previously. To find a semicircle, the formula is area is equal to pi times diameter squared over 8. Because in order to do semicircle cross-sections, these cross-sections are diameters of a semicircle. So you have to change your area formula of a circle or area of a semicircle into terms of diameters instead of radius. That's the formula. So when you make your integral, you're going to set it up very similar to this. Okay? Except instead of squaring the values, you're going to make semicircles out of this 2 and this the two inside pieces are just changing the inside. So basically, with all that said, your volume for the first piece is going to be pi r squared, or pi, in this situation, diameter squared. The first one's from 0 to 3. Pi goes out front. Oh, isn't it pi over 8 actually? Isn't it pi over 8? And then we just need to square the diameter. And the diameter, isn't the diameter, again, 2 from 0 to 3? Deja vu. It's just you have a pi over 8. And this one will be plus the pi over 8 again, from 3 to 3 plus ln 3. And will it be the same function? Yeah. And do you square it even? Now, here's what's kind of dumb. Can I pull a GCF of pi over 8 out? Whatever I get for this, isn't this answer just going to be times pi over 8? It's kind of redundant. It's the same question, it's going to have a pi over 8. So we kind of didn't even need to write all this. We could have gone, oh, it's the same thing once you saw this formula, and realized there's going to be a pi over 8 multiplied by the answer when you're done. But it just kind of visually, you can see it. It really takes some time to get used to how these look.